Mic checking 1 2. Mic check 1 2 1 2 1 2. Yeah, hope. Okay. Let us create a new project. Upload 3. What's up, guys? Welcome back to my channel. Thanks for checking in. So today we're gonna build a low frequency 3-phase, of which it's gonna use 12 from 12 volts to 48 volts. And it will be a low frequency. Then we'll do a high frequency, which will be a single phase, and it's 3. So it will be 3 phases which are not 180 degrees apart. Yeah, so don't buy a 3-phase inverter knowing that it's a 3-phase. It's just single phase duplicated 3 times. Sorry, I'm texting someone. So yeah, sorry, let's get back into it. So there is a many ways to skin a card. So today we are gonna use the easiest part. So we can use ESP32. ESP32, this board. Or the Arduino Nano. Let us use this for match, which will have a match. We can add or adjust the system. So we are gonna do the whole thing, which I'm gonna provide, and later on I'll provide a full schematic of this, of which I'm gonna tweak, make the schematics, the PCB layout, which I'll do later. And yeah, so with this we need 6 signals, of which will be 3 highs and 3 lows to drive the MOSFETs. Then the MOSFETs will provide power to the transformers, because this is a low frequency inverter. It's a low frequency inverter, and yeah, this is self-explanatory. So some things we'll watch out is that, because here I'm gonna be using a lot of high voltage, you should take care and watch out. So the Arduino, so the IGBTs, the MOSFETs, sorry. So yeah, so the MOSFETs are by the data we are making a three-phase inverter, of which is gonna provide from, I would say 10 to 30 or 10 to 40 kilowatts, and that will depend on the transformer that you use, but the board will be compatible with everything. So on that we need switching MOSFETs. So we need a MOSFET that can handle up to 60 volts, or 60 volts from 12 to, let's say, 12 to 70 volts, and then 12 to 70, and handle current of 100 amps and above. So one will be T15, T14, let's go through the data sheet. So power displacement is 300 watts, voltage is 150, that's okay, amperage is 140, that's very okay. So if you look at the diagram, let us open it, it's a diode. And another thing you should take in concern, it's the drain current, and the opening and closing of the gate will require 20 amps. So in our in this we can't directly link the Arduino to the transistor directly. It will die, it will burn. Let's see if they have this. They don't have it, so let's come here and look for the equivalent. 120 T120, So most of these MOSFETs aren't available. And then another person might be asking, why are we creating an inverter that will support, let me just close this. Why an inverter that will support, that will do all of that? So 630 amperes. Okay, 1580 D. None of these are above here, are mostly used commonly. Let's use Google. Yeah, so what in order to save time, because I just need the diagram, I'll use 44N, IRF 44N. So these are 55 volts, 49 amps. So let's just use these. So I guess 4 will do 300. Will do 300 watts very well. Maximum can do is 600 watts very well. So we'll just do it like that. So this we need 3 phases. So this is phase 1, let it just go up there. Phase 2 and phase 3. And it will do 4 4 4 4 4 4. Yeah, tomorrow is raining, so we need holes. $10mm. Guys, it's 10 mm. No, 10 mm is big. 5 mm. Yeah, 3 is good. But we need one there, so it should be one should be there, so that this and this should come here, and then this one should be here. So this is not the final layout, but let me just wire them up. So that is coming there, and that is coming there. So what you're doing is basically something like this, but in a higher scale. Yeah, that will do. So you just wire here, there, yeah. So basically this is just basic wiring of the inverter in the MOSFET section. Yeah, so the grounds are actually let me just delete this. Let me just use this instead. So one thing we'll need here, it's a resistor. No, 100 ohm. So I'm gonna use just 10K because in this this through hole, okay, let me just write here 100 100 ohm.